Hi, welcome to CreepGame Assignment 2.01. This assignment is an upgrade to our Pong game of last semester. This upgrade basically involves adding a graphics engine which can handle many graphical objects at once without knowing anything about the game at all, and it achieves this through the use of a callback system per graphical object. Let's go to the solution here, press F5 to run it. So here's a Pong game, just like last semester. I'll start a medium paddle. The AI paddle is on the left-hand side, which tries to mimic how a human player might play. On the right-hand side is my paddle, which I move with the W and S keys, but I'm going to put it into demo mode by pressing M, and that way it attaches an AI to the paddle on the right-hand side, so I can do other things without losing too badly. Now I'll press L to launch the ball. Now notice in this panel on the left hand side at the bottom, it shows some statistics here. It's basically showing that there is one vertex buffer allocated, 0 index buffers allocated, and there's a pool of 100 buffers available. There are 5 objects on the screen. That would be the right and left panel, the right and left wall, or actually scoring area, and the ball itself. That's 5 objects. The scoring area, the red area, is basically when the Pong ball enters there, it scores a point for the opposite side. So those are the 5 objects. You can see how many bytes they consume. So it's basically 80 bytes per object. They're all rectangles. They have 4 verts each, so that's 20 verts, and they're made up of 2 triangles, so that's 10 verts total. So I'm going to demonstrate the new capabilities of the Pong game, the Creep game, by pressing the letter O, which will add 1,000 mini Pong balls to the game. Press O now, and there's 1,000 mini Pong balls. If you look at the number of objects here, you can see that there's now 1,000 more, and there's quite a few more bytes and vertices and primitives. But you also notice that there's only one buffer still being used. So I'm going to add quite a few thousand more. There's 2, 3, 4, 5, 6, 7, 8. There's 9,000, and it's still only one buffer. But when I go to 10,000, it now uses 2 vertex buffers. There's now 10,000 mini balls on the screen. They all have collision interaction with the walls and the paddles. I'm sorry, the window boundaries and the paddles, not the wall. Walls is the scoring area. And you can see the frame rate's down a bit, but that's mostly because of the capture software. It'd actually be about 60 frames a second without the video capture software. So I'm going to exit the game with X, and we'll look a little code real quick. So basically, my graphical engine is called Render Engine, and it's got a number of functions. The more interesting ones are add geometry, which allows you to add more things to your scene. Update geometry, which is called per frame, and it basically for each geometry object, if there's a callback function, it calls it, and that allows the game to manipulate the object however it sees fit per frame. Draw geometry is called once per frame, which basically causes all of the graphical objects that need to be shown on the screen to be drawn, and it calls this draw all vertex buffers. So here's the draw geometry. You can basically see it just sets everything up, draws all the vertex buffers, and then tears it down. Actually, the display scene here is what tells the graphics device to display what it's been told about. And the update geometry basically says, okay, we don't know anything about a game except that we have all these callback functions. Let's call these callback functions, let the game interact. I don't really care what it does, let's just let the game interact with these objects. And here's the loop for the draw all vertex buffers. It basically causes all the buffers to be, all the buffers up here are unmarked, and as they get processed, they get marked. And this just says, get me the first unmarked one. Let me display all of the graphical objects in it. Then I want you to find me the next one of the same vertex type. This is an efficiency thing, and if there are none, just get me the next unmarked one, and I'll just start it all over with that. And down here is the update geometry. Basically says for all the vertex buffers I have yet to process, get me the next format, and for each of the vertex buffers in that format, if they're dynamic, because we only need to update dynamic buffers, then lock the entire buffer, and then for each geometry in the buffer, if the geometry is enabled, and if there's a callback method, execute the callback method and do that for all of them in this buffer and then unlock it. So that's pretty much an overview of my solution to this assignment. Thank you very much. Goodbye.